Okay, hopefully I've set things up so that things should record correctly. Um, all right, so good morning, good afternoon, good evening, wherever and whenever you are. I'm really honored to have been invited to be part of this talk and this event. So thank you very much for having me here. Um, for today, I'd like to present on some research that I've been doing that really are kind of two separate lines of research, but I think they tie together underlyingly. Uh, and really, the topic of the talk today is about how we say something and how it can provide important information about language production processes. So, how we say things can tell us about what's going on in our minds when we plan out whatever it is that we end up saying. And a kind of overall question throughout this talk will be, what can we learn about language production processes from what our utterances sound like? And I think this question can take two kind of like specific forms, or we can take it in different directions. One is we can think about the mental representations and the linguistic choices that shape our messages form. Depending on what we say, that may be reflected in how we say it. A very simple case is if I want to say the word cat, I'm gonna choose the appropriate sounds for that, right? Um, but more subtly, there's also ways where aspects of the language production process or processes could implicitly affect a message's form. And just a rough example of that is, let's say I'm having trouble accessing a word and I may need to buy some more time. And I say, could you give me the way I've said usually while I try to think about what comes next, is I've lengthened it and I've even changed the pronunciation, right? Um, One could argue that I wasn't really intending to say the word that way, but nevertheless, because of the production processes and the dynamics, it affected the phonetic form of the message. And so I'm going to be following these two lines of questioning throughout this talk. For the first half of the talk, I'll be presenting a behavioral experiment that uses production priming in an attempt to learn about how prosody is represented in the mind. And then I'll switch gears for the latter part of the talk to talk about using word durations to learn about the phonological encoding process in one of those more subtle ways. And in that case, what I'll present is a computational model that attempts to explain some of those underlying production processes and how we can relate them to word durations. So to begin, I'll start just briefly introducing prosody, which is always difficult to define, but here I'll define it as the intonation, rhythm, and intensity of speech, and the abstract meanings and functions that are often communicated through these cues. And I think this is maybe better explained through some examples. So I can uh, have a sentence, and depending on how I say it, I could slightly change the meaning. So I could have something like tap the frog with the flower. The words in the sentence could be ambiguous. For example, I could have a situation like this one on the left, right? Um, and I may say something like, tap the frog with the flower. I've used an intonational boundary after frog to indicate that the flower should be used to tap the frog, as opposed to something like, tap the frog with the flower, where now I changed the location of the intonational boundary, and frog with the flower is kind of perceived as a whole entity, which may be more likely to refer to this frog on the right. More relevant to the studies that I'm going to be talking about is the case of focus. So for example, if I say something like, I wanted the green book, I've emphasized a word here, in this case, green. And if you hear someone say that, you may infer that, oh, maybe this person received uh, a differently colored book, right? Because they've chosen to emphasize that green book. So you may imagine a situation like this, where the person received a red book and they emphasized green to distinguish, like, oh, I wanted a book, but it was the green book, not the red book, right? Um, One question within psycholinguistics, especially as it comes to these prosodic phenomena, is how do speakers assign the appropriate prosodic phenomena or constructs to their utterance? Um, what is that process like? And what are the relevant representations? These are basic psycholinguistic questions, but for prosody, somehow this has remained a bit mysterious. There's still a lot of debates as to what these should be. Um, and so in order to try to answer those questions, I look to inspiration in other parts of psycholinguistic research, right? So um, a lot of those questions have been answered for other areas of psycholinguistics through the use of priming studies, right? So priming very generally refers to when exposure to a stimulus affects subsequent behavior. It's a very general pattern, but it can be applied to all sorts of different situations, right? And so we've seen semantic priming studies where like uh, words with similar meanings may be activated and it affects how quickly people react to them. We've seen phonological priming, syntactic priming, where people may be more likely to use sentence structures in production that they've heard recently or read. Um, Nevertheless, for prosodic priming, this seems still a little bit controversial. It's not clear whether we've observed something that we could describe as prosodic priming. So there's been mixed evidence on whether prosodic representations can be primed. On the one hand, there's been some evidence for some studies, especially focusing on the implicit prosody. So people heard sentences with intonational boundaries in certain locations, and that seemed to affect how people disambiguated ambiguous, silently read sentences. There's also some general patterns where people's uh, suprasegmental cues like intonation and duration seem to kind of like uh, gravitate towards their conversational partners throughout a conversation. But there's, I think, still a question as to whether um, the underlying linguistic representations, the underlying linguistic choices can be primed, as we've seen in something like syntactic priming. Uh, some of the studies that tried looking into this more directly found a lack of evidence. So they've tried priming prosody and experimental studies, and they found no evidence other than priming something like speech rate, so just how quickly people could speak, but none of the linguistically meaningful phenomena. And so that brings us to a big question, because then we may be left wondering, well, can prosodic productions really not be primed? Can we not prime prosody? And if that's the case, what are the implications of that? Does it mean that there's no separable abstract representations to prime? That would make prosody quite different than most other areas of language. Um, or is it that prosodic representations for some reason fade too quickly and we can't observe these effects? And then therefore, how can we learn about what these representations may be? Um, Before concluding these, I think it's worth exploring the issue a bit further. And I have a hypothesis as to like why um, these studies have yielded mixed evidence. And I think it may be that um, previous studies did not find evidence for prosodic priming because there was not enough of a supportive context to observe it. And supportive context here, I mean very generally. So, for example, some of these previous studies, they maybe had participants hear a prime where they heard something like the Mexican billionaire purchased a photo of the landscape at the auction with certain focus accents on some words. And then they get a target sentence that they have to read and then produce out loud. And they see whether people are more likely to produce their own uh, focus accents in this sentence. Um, one possible thing that may be going on here is that here people aren't really producing their whole sentence from scratch, which may be a crucial part as to like deciding what words to emphasize, for example, right? So that's what I'd like to follow up on. So for our experiment, these are inspired by classic syntactic priming experiments. So there's an exposure phase where participants hear recorded sentences, which may or may not contain a contrastive accent. And then there's a production phase. So in this production phase, participants produce a sentence where it is optional to include a contrastive accent. For each trial, there's 2 sentences per phase, which is done to provide enough of a context where a contrastive focus is felicitous, where it would feel natural to produce a contrastive accent. So let me walk through kind of like what the task um, might look like to give you an example. So a participant might see a screen like this. You'll see that there's differently colored shapes and yeah, like throughout the screen. And they'll hear a recording that may say something like, click on the blue star, right? Once they click on the blue star, they'll hear a second recording. It's going to tell them to click on something else. And now it may sound something like, click on the red star, right? So with emphasis on red to differentiate it from the previous figure, the blue star, right? After they've done that, they may see another screen kind of like this, new shapes, and now their job is to produce an instruction of their own. So they're going to see one of the shapes flash. Excuse me. All right, I'm having a bit of a messy situation, but they may see something like a purple cloud flash, and they'll say something like click on the purple cloud, and then they'll see a yellow cloud flash, and then they may say something like click on the yellow cloud, or click on the yellow cloud is what we'd hope to see, right? Apologies for the, I'll fix the flashing here. Oh my. Okay. So for our design, we had prime manipulation, where we basically manipulated whether the participant heard a contrastive accent before producing their own instruction or not. So for example, in the prime case, they may have heard first click on the blue star, then click on the red star with the contrastive accent. In the no prime condition, they may have heard something like click on the blue square, click on the red star. No contrastive accent there. And we have a context manipulation. This is on the production phase. So does the context license the production of contrastive accent? We have a modifier focus condition where people first would have had to give the instruction, click on the purple cloud, and then click on the yellow cloud. So we've made them be both the same type of shape, but with different colors to see if they can now produce that contrastive accent there, as opposed to a neutral condition where the shapes are different and they may have to say something like click on the purple heart, click on the yellow cloud, right? Here, if they do include a contrastive accent, it sounds a bit awkward, you know, click on the purple heart, click on the yellow cloud, right? Because that's not the where the focus should be. So for our study, we had recordings from 35 English speakers. Each of these speakers completed 60 trials each. We had some technical difficulties where sometimes the recordings were crashing before the end, but for the most part, we got them. And we had 1,826 productions that we could analyze. So in order to make sense of our data, we had 2 raters listen to all the recordings and report whether they heard a contrastive accent on the modifier or not. The raters were blind to the condition, so they were listening to the productions and marking whether they heard a contrastive accent on the modifier, but they didn't know which condition the recording came from. They didn't hear the immediately preceding instruction that would have given context as to whether it made sense to include a contrastive accent or not. And the order was all randomized, so they shouldn't have had a strong bias or knowledge that could guide their decision beyond their own perception. This is roughly inspired by rapid prosody transcription, which is a process that has been used successfully to kind of analyze and find and transcribe prosodic phenomena in previous studies. Now, as to what I predicted would happen is something like this. So here on the y-axis is the proportion of accented productions according to the raters. And then on the left, we have the neutral context, so cases where it wouldn't have made much sense for the participants to produce a contrastive accent. On the right, we have a modifier focus condition, cases where the context kind of allows for a contrastive accent. And then we have the black dots are the no prime condition, and the orange dots are the prime condition. And so again, these are predictions. These aren't the real results yet. So what I expected would happen is that in the neutral condition, because the context isn't there to really support or facilitate the production of a contrastive accent, people would just basically not produce contrastive accents. These rates would be pretty low, right? As opposed to in the modifier focus condition, we'd see that in the no prime condition, people still produce contrastive accents some proportion of time, but then if they're primed to do so, now they're more likely to include that contrastive accent, right? And so that's kind of what I expected would happen. What we got was a little bit different. So here are the real results. The graph is, of course, oriented in the same way, but we get a slightly different pattern. So what we seem to get is mainly a main effect of prime. So it does seem like, at least numerically, in the modifier focus condition, people are more likely to produce a contrastive accent in the prime condition than the no prime condition. But crucially, the biggest difference of the prime condition is coming from the neutral context, which is a bit surprising. This was the context where I initially thought it would be very awkward to produce a contrastive accent. Nevertheless, that seems to be where the prime is making a difference. So we see evidence that the production of contrastive accents can be primed through recent exposure. That's, I think, really exciting. It's fairly new, but we do see an unexpected pattern. It's maybe a more puzzling pattern than what I expected, in that there's a main effect of prime rather than an interaction, right? And that brings us to an obvious question, which is why would that happen, and what does that say? So I have some thoughts as to what may be going on here. One possibility is that the contrastive accent production and the modifier focus condition, firstly, may be at ceiling. I think that's maybe one piece of the puzzle. So if I look here, both of these results, the black dot and the orange dots in the modifier focus condition, they're around 0.5, around half the time they're being reported as having had a contrastive accent. That's not ceiling in the sense of like being near 100%, right? But in all these cases, these are optional. You don't really have to produce a contrastive accent. And so maybe it's the case that in that context, if people are already pretty close to that 50% mark, it's kind of hard to push those rates much higher than that, right? So maybe that's part of what's going on here. But crucially, to explain this case here, where in the neutral condition, the orange dot is higher than the black dot, maybe what's happening here is that even though if you only consider one trial, including contrastive accent in this neutral context is really awkward and sounds very off, maybe when you consider that people are doing this for 60 trials, and that maybe within a trial, a contrastive accent may be odd, but there may have been recent context that would have made it less awkward, right? So even though it may sound awkward to say, click on the blue cloud, click on the red star, it may become a little bit less awkward if maybe 2 trials ago you just mentioned a blue star or something like that. So that's something we're certainly looking more into. So less straightforward pattern than we expected, but nevertheless, I think there's promising evidence that prosodic productions are primable. At least that gives me hope that we can use this to continue learning about prosodic productions. And so it's worth thinking about, like, well, what do we learn from this so far, right? Um, and I think there are some key takeaways. So firstly, prosodic priming does not seem to occur at a purely phonetic level. At least I wouldn't think so. I think if that were the case, some of the previous studies that specifically look at prosodic priming in these kinds of contexts would have found evidence for it, right? We also don't think that's going on because even when we listened and when the raters reported having heard a contrastive accent, uh, speakers produced contrastive accents often in their own way. They weren't necessarily um, kind of like following exactly how the recording that they heard produced that contrastive accent. Um, Also, given that the result does find some evidence, it seems like there needs to be enough of a supportive context to observe prosodic priming. And that may mean that people should generate the whole sentence, from scratch, although of course you can give them a lot of information so that they can do that. Although figuring out what exactly the factors are, I think is an important next step. Um, there's some follow-up studies and analyses that I'm excited for. So we're currently uh, trying to analyze the suprasegmental cues like acoustic measurements and the such. So we've been transcribing a lot of recordings in order to do so, and excited to see what we find out. Um, we also have an ongoing study that is looking into how specific is prosodic priming, because in this case, we kind of set things up to be, uh, for the transfer to be pretty easy, right? They hear a contrastive accent on a modifier word, a color word, and then they get the opportunity to produce a contrastive accent on the color word once again. But can we move things around? If they hear a contrastive accent on the color word, can people now be more likely to include a contrastive accent on the noun if it's appropriate to do so, right? And hopefully that can give us some information as to like how these prosodic categories or constructs are represented, how it operates, and how flexible they are. Okay. So far, I think we've got some promising evidence that prosody is not that different from other levels of linguistic representation. Um, and I'm hoping that this effect or this pattern could be used to learn more about language users' mental representations of prosodic phenomena in much the way that we've used, for example, syntactic priming to kind of probe mental representations of syntax. So this has all been an example of a message's form reflecting underlying linguistic choices, right? Maybe the most obvious way in which internal representations and production processes affect a message's form. Um, for the rest of the talk, I'll be switching to an example of how the message's form can reveal nuances about underlying production processes. And so this is research on phonological encoding. So phonological encoding refers to the processes that go on as we assign uh, the phonological form of a message. So maybe turning abstract word representations into actual sequences of structured sound, right? And the question in psycholinguistics for a long time is like, what is this process like? How does that work? And of course, there's been many years studying this. And so there are, I think, some key, very important aspects that we've learned. We know, for example, it's a flexible process. It's flexible enough to allow speech errors to go through sometimes, right, when we make mistakes. And there's a benefit to that because we need some flexibility in case we need to say new words, right? So the system can handle that. It's also a structured process. So even when we make mistakes, these errors aren't random. They seem to follow certain rules, position effects, for example, things like that, right? Um, Now, delving into it more deeply, how can we learn more about the phonological encoding processes? And traditionally, I think there's been two big sources of information, or kind of like ways of getting clues as to how this process works. There's been speech error data and speech onset latency data. So how long does it take for someone to kind of plan out and start talking, start saying the words, right? Um, for my research, I want to propose that word durations can actually serve as a useful window into the phonological encoding processes. And I think there's some benefits to that. And so I want to focus on two phenomena that are usually treated as being separate, but I'm going to try to explain them as being kind of two sides of the same coin. So these are phonological overlap lengthening and form repetition reduction. So phonological overlap lengthening is this effect that, or phenomena that has occurred. It's been found in many studies. I think the classic one is Sewald-Dell 1994, where speakers were slower to produce words if they had recently produced words that started with the same phonemes. So in this study, people were given uh, pairs or different numbers of words that they had to repeat as fast as possible, right? So for example, they were given pick and pin, and they just had to say those words as many times as they could in an 8-second window. So they'll go pick, pin, pick, pin, pick, pin, or pick, tick, pick, tick, pick, tick. And of course, the words are related to each other in different ways phonologically, like pick and pin share onset segments, pick and tick share rhymes. And the study found that when the words shared word initial phonemes, people seemed to slow down. They were able to complete fewer productions of a word. And so they gave an explanation, and they said that this suggests that phonemes were selected sequentially uh, for production. And so this is kind of the explanation that they give. So if you have a case where you have to say pick, pin, um, when you select those first sounds, p, right, that matches with both pick and pin, right? So say you're trying to say pin, you select the first sound, p, both the words pick and pin are going to receive some activation from that, right? And both are going to send activation to their respective phonemes. So is the next phoneme that needs to be selected. No problem, that may get selected, but that fits with both pick and pin also. So by now, both pick and pin are getting a lot of activation. And then in this last step, where you kind of have to make a selection that's actually going to mark a difference between these two words, um, you get extra competition, right? You may be trying to say pin, but pick is now getting a lot of activation because everything you've produced so far matches it pretty well, right? And so the system may need to buy some more time in order to successfully produce these words. This doesn't happen if the phonological overlap is word final, because say you're trying to say tick, you select t, you aren't really getting much interference from pick, and then the whole overlap that happens after that, it's all kind of leading to the selection of the same phonemes, and so it doesn't really hurt, so to speak. Um, so there's been many studies following up on these. Some of them are my own. And many of those future studies have focused on measuring word durations rather than completions in a window. Often they use event description tasks. So tasks like these, where um, people see different shapes, and then maybe one of them shrinks, say the hand shrinks. Uh, they'll just have to describe that. So they'll say the hand shrinks, and then maybe they see the hat flashes, and they just have to say the hat flashes, right? So we know that these overlap effects generalize to all these slightly more naturalistic sentences, so there may be intervening words and the effect still holds. It also seems to be sensitive to metrical similarity and stress patterns. And in one of my studies, we found that the effect happens even if the speaker has only heard a word that shares those initial phonemes. So it's not even necessary for the speaker themselves to have produced that other potential competitor. Even just hearing, for example, hat makes you lengthen hand. Uh, and it does seem to be a phonological effect. Like even if the phonetic instantiation is slightly different, the effect still holds. Importantly, in the past, I had proposed a computational model that predicted which words should be lengthened and where, depending on the phonological similarities between the words that the model produced. And the way that the model did that was by predicting durational increases based on the difficulty that the model faced in production. So this model found that durational increases were seen at points in a word where the model faced most difficulty. And so the model all percent is kind of following up on this. Before I describe that model, I'll talk about the other phenomenon very briefly, which is repetition reduction. I think it's a bit simpler to explain, just that words tend to be produced with shorter durations when they have been recently produced by a speaker. Um, this actually occurs even if the speaker is repeating a word that was first produced by someone else. So similar to the overlap effect, right? The speaker could hear a word and then repeat it, and it'll still be shortened relative to a case where no one has said that word before. And the crucial thing seems to be the phonological form. So even homophones, if someone says pie, like the number pi, and then pie, like the pastry, that still results in reduction. So here's my hypothesis for this model or this project, which is that phonological overlap lengthening and repetition reduction both emerge from the same source, which is the relative difficulty of planning phonological sequences, right? So basically in the phonological overlap lengthening, people tend to lengthen those words that overlap because producing overlapping sequences leads to interference, so to speak. It's harder to fully produce that sequence, and so the system slows down, right? In repetition reduction, we get kind of, once again, the other side of the coin. You're repeating a sequence that has been recently processed, and so it should be easier. Therefore, it should result in um, a faster process of selection. And so what this model intends to show is, or at least test, is whether the same mechanism can explain phonological overlap lengthening and repetition reduction, just as emerging from the same source. And I think the key part of the puzzle in order to make this work is incremental learning. So what I propose is that the production system learns with each production of a sequence, right? It updates its weights to make whatever it's just produced be, easier in the future, and that is going to explain both phonological overlap lengthening and repetition reduction. Let me very quickly show you the model. I won't go too deep into it, but this is not a big modern fancy model. It's not an LLM or anything like that. This is like an old school psycholinguistic model. Is inspired by simple recurrent networks, which were first described in the 80s. It's a type of neural network that can be trained to represent and encode serial order, right? This is not nearly as complex enough as we need our language production system to be. But what I hope to show is that just this aspect can yield the effects that we want to see. So the model's task is to produce words. It takes a lexical representation as an input, and it produces a string of phoneme representations one by one as an output. The model learns after every production of a phonological sequence. And what we're asking is, when is a word easy for the model to produce and when is it difficult, and whether that matches the cases where people tend to shorten and lengthen words respectively. Um, this is a schematic of the model. It's not very simplified in that this is basically the whole model with its whole lexicon, right? The model gets an input, which maybe represent a word, and then its job is to kind of one by one produce the phonemes that would make out that word. So the model is trained on a small lexicon and then produces sequences of words. And then we can manipulate how those words are related in order to have our conditions. So we can have a control condition, like for example, if the model produces fool and then bear, right? Those aren't related words. We can have an overlap condition. So the model produces bin and then bear, right? They both start with the same phoneme. We have a homophone condition. So different lexical representations, but the phonological output that it needs to produce are the same, bear and bear. And of course, we have a repetition condition where the model, produces bear, and then it needs to produce bear again, right? So for these, we use mean squared error of the output as a measure of production difficulty. It's basically how far away from the production target is the model in each of these conditions. And crucially, for all these comparisons, it's all on the same word. The only thing that varied was what word did the model have to produce right before, right? And so I'm going to show you the results now. So on the y-axis is the mean squared error. We see the control condition in black here. Here it's labeled critical, but it should be overlap. In the orange, we see that the model faces more difficulty compared to the control. That matches the kind of lengthening that we've seen in experimental studies. And then for both the homophone and repetition conditions, we see that the model faces less difficulty compared to the control, right? Which again matches the reduction of duration that we've seen in experimental studies. We actually trained 50 models, and here's how they all performed. It's hard to tell, but all I need you to see is that they all basically follow the same pattern with some kind of like slight exceptions, right? So the models faced more difficulty when producing words with initial phonological overlap. They faced less difficulty when producing repeated words and homophones, and this matches the patterns we see in word durations. And so I think what we can take from this is that phonological overlap lengthening and repetition reduction may have the same origin. This at least presents a way that can account for both of these phenomena, these patterns. And a crucial component of that seems to be incremental learning. That may be the mechanism through which these happens. So I'm excited about these results because I think these insights lead to some new untestable predictions. So overlap lengthening and repetition reduction are phonological in nature, at least according to this model, which means that we may be able to obtain these from non-words, for example, right? They also occur due to learning, so there may be ways to test out if there's a way of blocking learning. Does it also block these patterns from occurring, for example? And we may expand these to account for things like frequency effects too, right? Especially if you train a word much more than another, maybe we can start observing some frequency effects that have been found in the literature as well. And so just to conclude, what I hope I've shown is that what an utterance sounds like can give us some important clues about the processes through which speakers give form to their message. That speakers are more likely to produce contrastive accents after having recently heard one, as long as it makes sense to do so. And hopefully future studies will continue to yield information on the prosodic representations that we need. And that word durations can give us new information about the dynamics of phonological sequencing in production. And with that, I'd like to thank all of my lab mates and colleagues and all of you for having me. Thank you very much. And if you have any questions, please let me know.